We've all been there, right? Your code compiles, it even runs, but you've got that nagging feeling in the back of your mind. Is it actually right? Well, today, we're going to dive into a discipline that helps you answer that question with a confident yes, effective unit testing.
So let's start with that question, the one that every single one of us is asked. Your code works, on your machine anyway. But how do you stop that little voice that whispers, what if? How do you get real confidence that what you've built will hold up out there in the wild, under all sorts of weird conditions?
The answer, it turns out, really boils down to two big ideas that you have to tackle together. On one hand, you've got code coverage. This is all about making sure you've tested every single path, every little decision your code can make. And on the other hand, you've got data coverage. This is where you throw all kinds of data at your code, the good, the bad, and the ugly, to see how it reacts. You really can't have one without the other if you want to build truly robust software.
All right, so let's dig into that first piece of the puzzle, covering your code's logic. What are we actually talking about here? The goal is simple but powerful. Make sure every single line of code in your function gets executed by a test at least once. It's kind of like leaving no stone unturned, or in our case, no line of code untested. So how do you do that? Well, we can break it down into 4 key areas. First, you test the straight line code. That's the simple happy path with no decisions. Then, you make sure you test every possible outcome of your if statements and switch cases with branch coverage. After that, you tackle any loops with loop coverage to make sure they run once, multiple times, or even 0 times. And finally, you check that you're getting what you expect by verifying all the possible return values. Put them all together, and you've got a really solid map of your code's logic. Okay, so our logic paths are covered. We're done, right? Well, not so fast. What about the actual data that flows through all those paths? This is just as important, and honestly, it's where a lot of bugs hide. It's not that the logic was wrong, it's that the code got hit with some data it was never expecting. You really have to think defensively about data. You start with the easy stuff, good data, just to make sure the typical cases work as planned. But then comes the fun part. You try to break it with bad data, things like nulls, empty strings, or just plain garbage. You also have to poke at the boundary conditions, those tricky edge cases like 0 or the largest possible number. And finally, you check your pre- and post conditions to make sure your code leaves the system in a good state. So now we know what to test, our code's logic and the data it uses. But there's another level to this. What separates a test that just, works from one that's genuinely great? It comes down to a set of principles that turn your tests from a chore into a reliable safety net you can actually trust. And luckily for us, there's a fantastic acronym to remember them by. F.I.R.S.T. Your tests have to be fast, because if they're slow, you just won't run them. They need to be independent, so the failure of one test doesn't cascade and cause a bunch of others to fail. They must be repeatable, meaning they give you the same result every time no matter where you run them. They have to be self-validating, giving you a simple pass or fail, no need to read through logs. And finally, they should be timely, meaning you write them right alongside the code they're supposed to protect. Now, I can almost hear you thinking, okay, this all makes sense, but it sounds like a ton of work to set all this up from scratch. And you know what? You're not wrong. But here's the good news. We have amazing tools designed to handle exactly this problem. And the solution is called a testing framework. You can think of it like a complete workshop for your tests. It provides the structure, the tools, and all the boilerplate code to handle running the tests, reporting the results, and all that repetitive stuff. This frees you up to focus on the one thing that really matters, writing the logic for the test itself. This quote from Boris Bezer just nails it. The philosophy is that the very act of thinking about how to test your code forces you to see flaws in your design before you even finish writing it. It's a huge mental shift, and modern testing frameworks are built from the ground up to encourage this exact kind of proactive, bug-preventing mindset. So frameworks give you this really clean, repeatable pattern. You set up whatever your test needs to run, you execute the actual test method on your code, then comes the magic part. You make an assertion, which is just code that automatically checks if the result is what you expected. And finally, you tear down and clean up. That assertion step is the key. It's what makes the test self-validating and gives you that instant green check or red X. So, let's bring it all home. When you combine that deep code coverage with thoughtful data coverage, and you write those tests following the F.I.R.S.T principles, all powered by a good testing framework, you build an incredible safety net. It's a net that catches bugs while they're small, and it gives you and your team the confidence to refactor, to innovate, and to build better software without the fear of breaking things.
So here's a thought to leave you with. You don't need to boil the ocean and test everything all at once. Just think for a second about the most important project you're working on. What's that one little piece of it, maybe the most critical part, that makes you a bit nervous to change? What's one small, simple test you could write today that would make it just a little more reliable tomorrow?
If this helped you out, a like, share, and subscribe would be awesome. It really helps us keep these explainers coming. Thanks for watching.